In our development of the binomial theorem, let's begin with Pascal's triangle. This is a triangle that begins with 3 ones in a triangle at the top rows, and it's then followed by 1, 2, 1, 1, 3, 3, 1, etc., where in each row, each element is the sum of the two numbers above it. For example, on the next row, we will begin with a 1 and then follow that by 4, which is the sum of 1 and 3, 6, which is the sum of the two 3's in the middle, 4, and then 1. And the next row would be 1, 5, 10, 10, 5, 1. There are all sorts of patterns inside of Pascal's triangle, and the first thing you'll notice that each row is symmetric. It reads the same forward and backwards. Now, let's look at some things we already know. We know that anything to the 0th power is 1. We also know anything to the first power is itself, in this case, a plus b. But I'd like to highlight that this is the same as 1a plus 1b. And if you were to multiply a plus b times itself, you would have a squared plus 2ab plus b squared. Notice how we would then have coefficients of 1, 2, and 1. Now let's look at what we got here. 1, 1, 1, 1, 2, 1. And if you go up above to Pascal's triangle, isn't that the same? 1, 1, 1, 1, 2, 1. So these numbers in Pascal's triangle are binomial coefficients. The next row of Pascal's triangle begins with 1, 3, 3, 1. So let's take this down below here and write out 1, 3, 3, 1. Now let's look at something else from the line above. With the a's, we began with a squared, dropped to a to the first, and then no a's at all. We had a descending order of exponents for a. And then for the b's, there were no b's, 1b, 2b's. We had an ascending pattern of exponents for b's. So let's begin this with this next one, a plus b cubed. We will begin with a to the third, then a to the second, then a to the 0, which we can just ignore. And then with the b's, begin with no b, a single b, b squared, and b cubed, and then add these terms together, and you will have a plus b quantity cubed in a rather quick way. Let's do this now with c minus d quantity cubed. Our coefficients again will be 1, 3, 3, 1. And we will begin with c to the third, c to the second, c to the first, no c at all. And then negative d, not at all, followed by negative d quantity squared, and negative d quantity cubed, with plus signs between all of our terms. Sorry if that was a little tight of a fit. And we then have c to the third minus, because we have a negative to the first power, 3c squared d plus 3cd squared minus d cubed. Notice how the terms alternate back and forth. Now let's look at kind of a more challenging problem because we have something to the 5th power. Looking up above, our coefficients are going to be 1, 5, 10, 10, 5, and 1. And we will have to insert that into our pattern here. So we will have that this binomial to the 5th power is 1 times 2x to the 5th power, skip the minus 3y's, plus 5 times 2x to the 4th power times negative 3y, showing up for the first time. If you want to put a little first power, you can. And notice that for each term, the sum of the exponents is 5 when this is a 5th power problem. Plus, we now need 10 times the 2x will drop to the third power, and we will have negative 3y to the second power. I'm going to skip a line here. We will now follow this with plus 10 times 2x to the second times negative 3y to the third, plus 5 times 2x to the first times negative 3y to the fourth, plus 1 times negative 3y to the fifth power. Now, instead of writing my answer down below, I'm going to put each term next to its expanded format up above. This is going to equal, in red, 2 to the fifth, which is 32, times x to the fifth, minus, we will have 5 times 2 to the fourth, which is 16. 5 times 16 is 80, times negative 3 is negative 240, x to the fourth y, plus, this will become 10 times 2 cubed times negative 3 squared. 10 times 8 is 80, times 9 is 720, x to the third, y to the second, minus, okay, we've got 10 times 2 squared, that's 10 times 4, which is 40, times negative 3 cubed, which is negative 27, which gives us 1080 x squared y cubed, plus, okay, now we have 5 times 2, which is 10, negative 3 to the fourth is 81. 10 times 81 is 810 xy to the fourth, and finally minus 243 y. That is a whole lot faster than multiplying 2x minus 3 times 2x minus 3 5 times and doing all that distribution.